Why can't a hydraulic press crush extremely hard objects into pieces with what looks like just a gentle push? Where does all that force actually come from? The moment the motor starts up, the hydraulic pump begins spinning at high speed. It pulls hydraulic oil out of the reservoir and forces it through the pipes inside the machine. There are two key valves. The directional valve controls where the oil flows, which determines whether the press moves up, down, or pauses. The pressure valve acts like a safety guard. If the pressure gets too high, it automatically releases the excess oil pressure back into the tank to prevent the machine from being damaged. Because the most dangerous thing about a hydraulic press isn't that it lacks power, it's that it has too much. If the pressure ever goes out of control, thousands of tons of force instantly rupture the pipes. The real work is done by the hydraulic cylinder. High pressure oil pushes the piston inside the cylinder, converting fluid pressure into mechanical force. And the secret behind the force multiplication is Pascal's law. Pressure inside a sealed liquid is transmitted evenly in every direction. A hydraulic press uses two pistons, one small and one large. You apply a small force to the small piston, and that pressure gets transferred through the hydraulic oil to the large piston. Since the large piston has an area dozens or even hundreds of times bigger, the output force also becomes dozens or hundreds of times greater. The trade-off is speed. The larger piston moves dozens or hundreds of times slower. That's how a relatively small input force can easily generate thousands of tons of crushing pressure.